All right, so welcome to At the Bench with Quad Standard Labs, Troy, Chef PV, and we've got three different drones on the table here with three different ways that we've run motor wires. Now, typically, we see a lot of different people running motor wires a lot of different ways. One way in particular that at Quad Center Labs I just kind of refuse to do or don't really like to do, and that is the method in which you wrap the motor wire underneath the flight controller and around the post and then come back to the pads. People kind of feel like this is kind of like a clean methodology. The reason we don't do it is for lots of them. The main one being electrical noise running right over the components that are basically the noisiest on your flight or on your drone, which is the ESCs. And then it's also basically sandwiching that between the flight controller, which is the most susceptible thing to electronic interference and electrical noise. So it just doesn't make a ton of sense for me to run them that way. Number two, for a lot of new builders, they make a lot of mistakes with how short they get the the silicone wire and how close they get the wire to overlapping other components. By doing that and all the solder splatter that can go along with soldering on top of other components, it just makes for a hazard that I just don't really appreciate or don't think is really worth the risk. That being said, there's lots of ways to run really clean wiring. So we're going to show you three examples here today. Um, we've got a squirt. So this is an example of where a flight controller is more forward than the center point, and we had to make different links for the front wires, different links for the back wires, and we also had to angle them in order to get them out from underneath the duct. Now, some people would cut the duct on a squirt and just have the wires run through it. That's not the way it was intended to be functional, and it kills some of the efficiencies. So taking the wire and letting it hang loose, and then what we do is we put some nice tape, the same tape that we use, the Tessa tape on all of our wiring. We put a little bit of that in between here, and we keep it nice and secure, and it's out of the way underneath the duct and in between them, and it doesn't get caught up on anything, never has a problem. But what you'll see is to keep all of these wires nice and in line, what we had to do is we had to angle each one. Now, we just angled them back at about, 60 degrees back, and we started staggering them all the way back. You have to be really careful that when they get kind of close, you can't get them too close. And again, you got to be good with the wire management and the silicone. Make sure that you don't leave too much overhanging to where they touch. So that's this methodology of just leaning them back at a certain angle to kind of get them not straight out. So that's one methodology or one reason that we might do them sideways. Now, after looking at the angled method, we're going to go ahead and look real quick at the straight method. So this method here is just your typical, just straight on. This is a geyser. So again, we're keeping the wires in between the ducts so they come together, and you can see that piece of tape that we use to kind of bunch them together. And then on this one, it's going to go straight in because we're center stacked. Now this is going to be the best way to do it, really. It's the cleanest, if you would, in terms of you're not having to get really close to the FETs. You're not soldering on top of components, and it leaves the wires in the less stressed kind of position as possible. But for a lot of builds, again, you're not going to really have this methodology because you're going to have a full Truax frame. This is just an example on a Cinewook. So we've got two Cinewooks with different directionality, and now we're going to get to just an open prop DC5. Now, this build here is actually got the angle, but the angle is actually going upward. So we came in with the first pin, so the very first wire, we came in here and we soldered. Then we came in over top of it with a slight angle back and soldered. Then we did the third one, right? And we have three more that we're going to show you how we do it right now. But on the other side, you can see we did it both ways. So now what you end up with is a really nice, clean, kind of almost like a V, if you would, channeling kind of going with the wires. And these wires can stay straight up in the air like this, or we can kind of bring them and tuck them inside the frame now. And we could even technically kind of tie those together if we wanted to keep them nice and clean. We shouldn't need to. 5-inch props on this drone actually don't come too close to the body, so it should be fine just the way it is. And honestly, I like the nice clean look of how that wiring management kind of turned out. I love to leave just a little bit of loose wire. So if you ever do break an arm or a motor for some reason flies off, you're not ripping at these pads. What you could do is you could do a zip tie also right here to the standoff. I'm not going to do that just because it's raw bare wire. If we were going to do that, I would have wrapped the wire probably in some Tessa tape, but I think it'll be fine like this. And so I'm going to bring you in a little closer, and we will take a look at wiring up this last 3 pads. And we're going to talk about a couple of things while we do this. Mainly, we're going to give a couple of quick tips for soldering methodology and how to make sure that you have a nice clean solder joint. So one of the first things you want to do is the wires themselves. We're going to use our fingertips and we're going to just clean those up and spin them in our fingertip to kind of make sure that all the little stray ends and all the little pieces of wire are all wrapped together nice and cleanly. We're going to do that to all 3. And then I'm going to use my forceps, my bent forceps, or, oh, there we go. And we're going to go ahead and get these tinned. Now, when you're tinning wires, what you're trying to do is you're trying to ensure that you have proper, complete flow of solder and or flux. In my situation, I am using a keister solder that has flux resin cores, so we don't use a lot of flux pins or anything. It's just for us no point. So a couple of tips which you're going to want to make sure you do: be in a ventilated area first of all, have a fan and or mask. I have both going right now. You're going to want to make sure your tip is clean, your iron, and is ready to go with a little bit of nice clean solder on it. We'll even put just a little dab of it. Next thing, we're going to hold that to the wire, and then we're going to put the solder on the wire. So we're doing this to make sure that the solder flows through the wire and not just on the tip of the soldering iron. So when it's heated up, I should be able to flow right through it. I want to be really careful about drippage and not letting anything drop into a motor or onto a board. So again, we're going to heat up. We're just going to make sure it flowed all the way through here. There we go. Move on to the next one. Oh, not getting that heat transfer into the wire yet. If you're having a hard time getting it to kind of heat the wire up, hold it at the tip of the wire. Oh, my iron was going down. That was why. Don't force it. If you ever notice that, hey, something just doesn't seem right, make sure you check your iron. You can see that it's cold because it's not going into the wire. I should have noticed that, but because of the camera angle, it was hard to see. You can see here where it flowed all the way into the wire. All right, now we're back up to temp. There we go. It's flowing into the wire nicely. There we go. And again, you can start at the tip and then slide the iron underneath. It really helps get like the heat penetrated into the wires. All right, so we've got 3 nicely tinned, so there's enough on each one. Now you can see this third one is a little long. So what I'm going to do is I'm going to use my wire cutters, because again, this is all about making sure that you have proper wire management. And we're going to cut the tip off. Now make sure when this tip comes flying off that you find it and you throw it in a trash can, in a bin somewhere. You want to keep something like for trash like that you always have. And the reason is that little piece of wire and solder can get into a motor, get sucked in, and it can really do some damage. So we've got our 3 tinned wires. The next thing is if the tip of your iron is properly heated and you have a proper amperage soldering iron, this should be easy, and proper technique would be to hold the iron to the pad, and then as the iron heats the pad, you're going to bring the solder to the pad, not the iron. So you're going to see I'm holding it to the pad, and now when I bring the solder to the pad, it's melting. I am touching the iron a little bit because I have to, and it flows right over. It shouldn't take more than about a second or two to heat the pad up and get full flow of solder on that pad. It should flow right into it nicely. Again, this is rosin core solder, so it's flowing very nicely and cleanly itself over everything. All right, so next up, what we're going to do is we would use, and we're going to try to do this as cleanly as possible, but one tip to soldering, the number one tip probably, don't solder on camera. Yeah, no, soldering on camera is always the worst. Okay, so we're going to start with the furthest away, which is actually, so it's the far wire, but it's actually going to be the closest. And the reason we're doing that is it's got to go in first so everything else gets angled and plays off of it. So I'm using my tweezers here because tweezers are awesome, and I've just got to grab it the right way. And we're going to basically, let's see if I can get this angle right. I'm going to heat the pad and the wire at the same time and pull right off. And there you go. It's nice and clean. It shouldn't take more than about a second because of the heat is right and everything is properly tinned. It only takes a brief second for everything to heat up. So again, let me see if I can get this in. So I have the pad and I have the wire touching the pad, and I'm basically slipping the iron right in between and heating both up. Not pushing anything, I'm just letting it heat up, and as soon as it heats up, I push them together, or I let them come together, and now I'm angling it slightly backward. So I've got a straight up wire, and it's angled just slightly backward. Same thing one last time. All right, that one I need to get. All right. It's going to cause problems with the USB just slightly. We'll be all right. All right. So we've got all those wires nice and cleanly on there now. As you can see, everything in that V pattern kind of angled backwards. Nothing's touching. I don't have any motor wires that are gonna like rub up against each other or short out the pad next to them. Everything is nicely wire managed. So that is a good methodology for not going inside and over the top of the ESC. You can do it like this, and you can see if you wire it and keep it nice and clean and tight, there's no reason why you can't wire something like this and keep it in there without having to go wrapped around. Hope you enjoyed. Let us know what else you'd like to see, and tune in to the next At the Bench with Quad Standard Labs. Thanks for watching.